Imagine a world wrapped in warmth, a planet that had never known the glaciers and ice sheets that would one day form. 66 million years ago, the Earth was a place of gentle abundance. There were no polar ice caps, no frozen wastelands where penguins would one day gather. Instead, shallow seas covered much of what would become North America and Europe, and the continents themselves existed beneath a thick blanket of tropical warmth. Even at the poles, where we now expect nothing but barren snow, forests grew dense and green, their canopies reaching upward in eternal summer. The oceans were shallow and warm, rich with life, their waters teeming with ammonites and belemnites, with great swimming reptiles that glided through the currents like living islands. This was the world of the late Cretaceous, at the very end of that long geological epoch that had already lasted for nearly 80 million years, and dinosaurs had walked this world for 165 million years, far longer than humans have existed, longer than mammals have existed in any recognizable form. These were not creatures on their way out, not a dying lineage limping toward extinction. No, the dinosaurs were thriving. They were diverse. They were perfectly adapted to the warm, resource-rich planet that was their home. In the subtropical forests and grasslands that covered the land, Tyrannosaurus rex was the apex predator, a creature of muscle and intelligence and terrible hunger, perfectly suited to its role. Triceratops grazed in herds, their three-horned heads bent toward ferns and cycads, their bodies massive as any land animal Earth had ever produced. Edmontosaurus moved in families through the forest understory, their thousands of grinding teeth processing vegetation, their social structures complex and perhaps affectionate. In the sky, pterosaurs still soared on leathery wings, though they were beginning to yield to a new group of flying creatures, the birds, which were spreading and diversifying with remarkable success. In the oceans, vast mosasaurs hunted with sinuous grace, their paddles carrying them through depths and across open waters. Turtles moved slowly through the shallows, unchanged and content. The shells of countless mollusks glinted in the filtered sunlight that penetrated the clear, warm seas. The food chains were complete, the ecosystems were balanced. The living world had adjusted itself to a planet of warmth and light and abundance, and that adjustment had produced miracles of form and function. Everything was in its place. Everything was thriving. This was a living world at its peak. Then, on a day like any other, the first sign appeared in the sky. It began as a point of light among the stars, visible perhaps only to creatures whose eyes were particularly sensitive to the heavens. The light grew brighter over the course of hours. A star that was not a star, a light that was somehow wrong. Perhaps the pterosaurs noticed first, their keen eyes catching that strange brightness. Perhaps there were creatures that felt the air change, that sensed the approach of something terrible, though they could not have known the name of their dread. The point of light became a line of light. The line expanded, the brightness intensified. For 2 seconds, only 2 seconds, the asteroid that would end an entire epoch travelled through the Earth's atmosphere. 2 seconds. That is how long the warning lasted. That is how much time even the most alert creature on the planet would have had to perceive what was coming. The asteroid itself was a solitary thing, ancient and indifferent. It was not large compared to the Earth, not in the way that mountains are large or oceans are large, but it was enormous in comparison to anything alive, approximately 7½ miles across. 12 kilometers, it was a rock and iron and dust bound together by gravity and time, and it was travelling at a speed that the human mind struggles to encompass. 12 miles per second, 44,000 miles per hour, a speed so great that the atmosphere provided almost no resistance, no friction to slow it. It was as if the air itself had become transparent to this projectile, as if the sky parted before it like water, before a stone cast by a careless hand. The impact occurred in what is now the Gulf of Mexico, in the shallow seas off the Yucatan Peninsula. It struck limestone and gypsum, layers of rock that had been deposited during earlier epochs, rocks that held within them vast quantities of sulfur. It struck at an angle slightly south of the vertical, and the moment of impact released an energy that human beings have only ever equalled in the most terrible weapons they have ever created. 10 billion Hiroshima bombs, all detonating in a single instant, 2 million times more powerful than the largest nuclear weapon ever detonated. The energy was so vast that it is almost impossible to hold it in the mind. It would be like trying to imagine the distance to the stars or the weight of an ocean. The human brain rebels at the attempt. The only thing that might convey such a force is simply this: it was enough to change everything. In the first fraction of a second after impact, the asteroid compressed the rock beneath it, and that compression released a shock wave, a wall of pressure that travelled outward in all directions. The rock at the impact site was vaporized instantly, turned from a solid substance into a superheated plasma that expanded with inconceivable violence. The ocean directly above the impact site was vaporized. Millions of tons of rock and water and dust were launched upward and outward, a column of superheated material rising into the atmosphere like the trunk of some vast tree growing upside down, reaching upward towards space itself. The blast wave that followed travelled outward from the impact site at supersonic speed, a wave of pure pressure that would flatten forests hundreds of miles away, that would snap trees like stems, that would crush any creature in its path. The vaporized debris launched into the atmosphere began to cool almost immediately, condensing into tiny particles of glass. Spherules, they are called, each one the size of a grain of sand, each one fused from the rock of the asteroid and the rock of the impact site. These particles, millions of tons of them, were lofted into the upper atmosphere by the tremendous heat of the impact. They rose higher and higher, reaching the stratosphere, spreading across the entire sky. And then, over the course of hours, they began to fall. They fell back to Earth like a rain of hot glass, and when they struck the ground and the forests and the creatures below, they were still so hot that they ignited everything they touched. Across the entire planet, nearly simultaneously, forests began to burn. Not from the blast wave, though the blast wave had reached far, across the Gulf, into what is now Texas and Louisiana and beyond. The forests caught fire from the returning ejector, from the rain of hot glass particles that fell from the sky like a cosmic punishment. Scientists call it the broiler effect, and the name is apt. The upper atmosphere became like an oven, like the heating element of some vast appliance, radiating downward with tremendous intensity. The heat was so great that it ignited everything that could burn. Across the continents, wherever there were trees and plants and organic material, wherever there was anything that could fuel a flame, fire started. Not from lightning, though there was lightning in abundance. Not from the heat of the sun, though the sun was still shining. The fire started from the falling debris, from the heat of the impact converted into a rain of incandescent particles. In what is now North America, in what is now South America, across Europe and Asia and Africa, the forests ignited. The world became a place of fire, and the creatures that lived in those forests, the dinosaurs and the flying reptiles, and the mammals and all the small things that depended on the plants for survival, they were engulfed in that fire. Some of them died immediately. Others tried to flee, seeking water or caves or anywhere that might provide shelter from the heat and flames. But there was nowhere to hide. The entire planet was burning. The sky was dark with smoke and dust. The sun, though it shone as brightly as it ever had, was hidden behind a veil of ash and soot and smoke so thick that no light reached the ground. The day became night. The heat and the fire and the darkness came all at once, within minutes of the impact, within hours at most. Everything that had been stable and known and perfectly adapted to a world of light and warmth was suddenly irrevocably changed. And yet for a moment, if we might extend the metaphor of sleep and dreams, the creatures that lived through the first hour had no way of knowing that this was not a temporary catastrophe, not a storm that would pass, not a calamity from which the world might recover by sunrise. They felt the heat, they saw the fire, they heard sounds unlike any that had ever existed before, the roar of the blast wave, the rumble of the earth, the sound of forests burning. But their minds could not encompass what had actually occurred. The impact was too vast, too absolute, too unprecedented. It was as if the universe itself had fundamentally broken, and yet no creature alive had any framework to understand that their world had ended. The Chicxulub crater, for that is what this impact site would come to be called, named for a small town near the impact zone, created a blast radius measured in hundreds of miles. The shock waves from the impact propagated through the Earth's crust like ripples in a vast pond, spreading outward from the point of impact, carrying the news of the catastrophe to every corner of the world. And they would circle the planet multiple times, returning to the impact site after travelling completely around the globe, causing earthquakes of a magnitude that the Earth had not experienced in millions of years. Magnitude 10 to 11 on the moment magnitude scale. Earthquakes so powerful that they would have been felt everywhere on the planet simultaneously, that would have caused tremendous destruction everywhere at almost the exact same moment. The ground shook for days. The vibrations travelled through the bedrock and through the soil. Mountains cracked and shifted. Valleys opened up. The landscape was fundamentally torn open, reshaped by forces that moved slowly on human timescales, but with tremendous violence from the perspective of geology. And the oceans, those warm and shallow seas that covered so much of the continents, rose up in waves. Tsunamis, walls of water hundreds of feet high, raced outward from the impact site. These were not the small tsunamis that might be caused by underwater earthquakes or volcanic eruptions. These were waves of a size that would only be possible if the entire ocean had been displaced by the impact. 300 feet high or higher, these waves crossed the Gulf of Mexico. They surged up the coasts of what would become the United States and Central America. They raced around the world and they scoured everything in their path. Organisms that had lived for millions of years in particular places, in particular depths, in particular waters, were torn from their homes and scattered across continents. The structure of the ocean basins themselves was altered. But here is the remarkable thing. Here is the thing that fills the mind with awe when we truly comprehend it. Scientists found evidence of that first hour of extinction, evidence so clear and so striking that it is almost as if the impact itself left a record of that terrible moment, a frozen instant of deep time. In what is now North Dakota, in rocks belonging to the Hell Creek Formation, paleontologists discovered fish that had died in that first moment after the impact. Not weeks later, not days later, in the first hour. These fish, species that lived in freshwater rivers far from any ocean, far from the impact site itself in the middle of North America, had died with impact glass beads lodged in their gills, tiny spherules of fused rock and asteroid material, particles that could only have travelled there through the air, particles that fell so quickly that they were still in the process of falling when the fish breathed them in. In their final moments, as the darkness came and the heat descended and the world transformed, these creatures drew breath and took in fragments of the rock that had been vaporized thousands of miles away. They were nearly 2,000 miles from the impact site, and yet they were among the first victims of the event. This is the moment that science has been able to reconstruct with remarkable precision. This is the hour of extinction, the instant when the living world pivoted, when everything changed. It is preserved in rocks, in fossils, in the layers of the Earth's crust. It is written in the geological record like a story that has been waiting for millions of years to be read. And when we read it, when we reconstruct that terrible and beautiful moment, we are reading the most profound story that geology has to tell. The story of how a world can change in an instant. How the most successful creatures that have ever lived can disappear forever. How the face of the Earth itself can be remade by a single moment of impact. If you're using this to fall asleep, that's exactly why I make these videos. Maybe subscribe to the Calm Archive and let me know in the comments where you're watching from and what time it is. I always check the comments, and it's fascinating to see people from all over the world, all drifting off to the same ancient stories just hours apart. Anyway, back to 66 million years ago. As we drift deeper into this story, deeper into the past and into the mysteries of deep time, it may be comforting to remember that this happened long, long ago. This impact occurred 66 million years ago, in a world that no human being has ever seen, at a moment in Earth's history before anything recognizable as a human being existed on the planet. We are descendants of creatures that survived this catastrophe, of tiny mammals that huddled in burrows while the world burned above them, of creatures that were small enough and resilient enough to persist through the darkness and the cold that came after. The reign of the dinosaurs is over, yes, but their legacy lives on in the birds that still sing in the world today. And the calamity that ended their age also cleared the way for the age of mammals, for the evolution of primates, for the eventual appearance of human consciousness. In the long view of deep time, in the patient geological perspective that allows us to see millions of years as if they were a single moment, the Chicxulub impact is not merely an ending. It is also a beginning. It is the pivot point upon which the entire history of the modern world turns. And we are here, alive and conscious, because that asteroid fell. We exist in the light of that ancient darkness. We are, in a very real sense, children of the impact, born from a world remade by catastrophe, inheritors of a planet that was devastated and then slowly, gradually, miraculously renewed. Perhaps you can almost feel it now, the warmth of that Cretaceous sun on your skin, that eternal summer that had lasted for so long that no creature alive could imagine a colder world. Perhaps you can hear the sounds of the dinosaurs in the distance, the vocalizations of creatures whose voices have been silent for millions of years, the rustle of leaves in a prehistoric forest, the splash of water in warm oceans, the calls of pterosaurs in the sky. These sounds filled the world before the impact, and they are sounds that no human ear has ever heard, sounds that exist now only in our imagination and in the rocks beneath our feet. The Cretaceous world was a place of wonder, not as alien as we might think, yet not entirely familiar either. The plants were recognizable to us. Flowering plants had evolved not long before the impact, but they flourished in a world of warmth that we can barely comprehend. The ancient ferns and cycads grew alongside the flowering plants, creating a verdant patchwork of green across the continents. Insects swarmed through the air, and the insects of the Cretaceous were diverse and numerous, as they are in our world today. And then, in a single moment, that entire world was transformed forever. The asteroid did not slow as it fell. The atmosphere did not significantly impede its progress. It was as if the sky itself was made of glass, as transparent to this cosmic missile as the vacuum of space. The impact released its energy in a moment that was almost instantaneous from a human perspective, though from the perspective of physics and thermodynamics, it was a complex and unfolding event that lasted for precious seconds. Those seconds contained the death of an epoch. Those seconds contained the transformation of a living world into a world of fire and darkness. And perhaps, as you listen to this, you're already beginning to feel the pull of sleep, the gentle weight of the ancient past pressing down upon your consciousness, carrying you backward through time toward that warm Cretaceous world that ended so suddenly. Let yourself drift with that feeling. Let yourself sink deeper into the story of the impact and the extinction and the slow, gradual recovery of the Earth. For in falling asleep, we ourselves engage in a kind of death and rebirth, a small echo played out each night of the great transformation that befell the living world 66 million years ago. And just as the world recovered from the impact, and just as new forms of life emerged to fill the spaces left by the dinosaurs, so too do we awaken refreshed, renewed, and ready to face a new day. The first 10 minutes after the impact were a time that no living creature would experience and survive to remember. The impact itself had been instantaneous, an event that occurred in a fraction of a second, measured in thousandths of a second, a duration so brief that it exists at the very edge of what we can conceptualize as time. But those first 10 minutes that followed, they were an epoch in themselves. They were a period of transformation so complete and so catastrophic that the living world would never be the same. The vaporized material from the impact had been launched into the upper atmosphere in a column of superheated rock and vapor and dust. This column rose not just into the sky but beyond it, extending upward with tremendous force, spreading outward as it rose, pushing through the stratosphere and into regions of the atmosphere where the air was thin and cold. The material that had been launched into the atmosphere was still incredibly hot, not yet cooled to the point where it could remain suspended, and as it rose higher and higher, it began to slow. The edge of space approached, and then was reached. And then, inevitably, the material that had been launched into space began to fall. It fell slowly at first, catching air currents, spreading across the atmosphere like a vast cloud. But within minutes, it began to descend. Within 10 minutes, the rain had begun. This was not a rain of water, though there would be water too later. This was a rain of glass. Millions of tons of molten rock, pulverized to dust and fused together by the tremendous heat of the impact, fell back to Earth in the form of tiny spherules, particles of glass only a few millimeters across, but present in such vast quantities that they created a continuous bombardment. The particles fell from the sky like sand through an hourglass, and they were still hot from the impact. They were hot enough to ignite. Imagine, if you can, the sky darkening not because of clouds or because the sun was setting, but because it was being obscured by falling particles. Imagine the light of the sun being filtered through an increasingly dense veil of dust and ashen glass. The sky would have taken on a strange colour, reddish in some places, orange in others, everywhere darkened by the increasing opacity of the material falling from above. And then, as that material struck the forests and the grasslands of the Cretaceous world, imagine the heat. Imagine surfaces that had been cool and comfortable suddenly being bombarded by heated particles, particles that were still carrying the energy of the impact, particles that were more than hot enough to ignite anything flammable. The ignition happened in instants. Forests that had stood for millions of years caught fire in moments. The trees that had been growing in the tropical and subtropical regions of the world began to burn. The undergrowth ignited. The ferns and the flowering plants that covered the ground became fuel for an inferno that would rage across the planet. This fire was not confined to the impact zone. The returning ejecta, the rain of hot glass particles, fell everywhere on the planet. Everywhere that there were forests and grasslands and vegetation, fire began. The effect is called the broiler effect by scientists, and the name captures something essential about what was happening. The upper atmosphere, heated by the returning ejecta, was functioning like the heating element in an oven. It was radiating heat downward with tremendous intensity. And on that heat, everything that could burn began to burn. This was not a simple fire, the kind of fire that might be started by lightning or volcanic eruption. This was a planetary fire, a conflagration that encompassed the entire world, in North America, in South America, in Europe, in Africa, in Asia, in Australia, everywhere on every continent where there were plants and organic material to burn, fire started. The fire was so vast and so intense that it created its own weather. Tremendous columns of smoke rose from the burning forests, rising miles into the atmosphere, creating a pall of smoke and ash that circled the globe. This smoke, mixed with the ash from the impact itself, began to obscure the sun, not just in the impact zone, not just in the region around the impact site, but everywhere. As hours passed and then days, the amount of material in the atmosphere increased, and the opacity of the atmosphere increased with it. The darkness deepened. Within the first hour of the impact, organisms everywhere on the planet were experiencing an unprecedented catastrophe. This is the crucial thing to understand. This was not a local extinction. This was not a disaster confined to one region or one ecosystem. This was a global transformation, an event that affected every continent, every ocean, every ecosystem simultaneously. The creatures that lived 2,000 miles from the impact site were experiencing conditions as dire and as devastating as the creatures that lived in the impact zone itself, perhaps even more so. They had no blast wave to kill them quickly. Instead, they had hours of heat, and then hours and then days of darkening sky and falling ash, and the smell of smoke, and the sight of fires burning on the horizon. There is evidence of this moment, evidence that has been preserved in the rocks of the earth for millions of years. In what is now North Dakota, in the Hell Creek Formation, a layer of rock that contains the boundary between the Cretaceous and the period that would follow it, paleontologists have found something extraordinary. They have found fish that died in the first hour after the impact, not weeks later, not days later, in the first hour, within the first moments of the catastrophe. And these fish, creatures that had lived their entire lives in freshwater rivers in the middle of North America, far from any ocean, far from the Yucatan Peninsula where the asteroid had struck, had died with impact glass beads lodged in their gills. The tiny particles of fused rock, the spherules that had been launched into space and then rained back down on the planet, had fallen so quickly and with such density that when the fish opened their mouths to breathe, they inhaled those particles. They breathed in the impact itself. They took the asteroid into their bodies and it killed them. These fish died nearly 2,000 miles from the impact site. They died in what is now the western United States. They died in rivers and streams that had no connection to the Gulf of Mexico, no connection to the area where the asteroid had struck. And yet they died from the impact as surely as if they had been in the water directly above the crater. This is the remarkable thing about the extinction event. It was not localized. It was not something that affected one region while sparing another. It was planetary in scale. It was universal. It affected everything, everywhere, all at once. The Tanis site in North Dakota, discovered and studied by paleontologist Robert De Palma, is perhaps the most complete record of this first hour of extinction that science has ever found. At Tanis, layers of fossils and sediment and geological material tell a story of the exact moment when the extinction began. The impact occurred at a distance of nearly 2,000 miles away, but within hours the effects had reached this location. Sediments were displaced, rearranged and redeposited. Organisms were killed and buried, and all of this happened within such a short period of time, within hours, perhaps even within minutes of the impact in some cases, that the record at Tanis is essentially a snapshot. It is a moment frozen in time, a geological instant preserved in stone. Here, in these rocks, we can read the history of the extinction as it was happening, in real time, in the first hours and days after the asteroid fell. In the days that followed the first hour of impact, the darkness continued to deepen. The sun, which had been obscured by the initial cloud of ejecta, remained hidden. The sky, which had been darkened by the impact glass and the ash, grew darker still. The fires that had burned across the continents began to diminish, not because the fires were going out, but because there was less and less light to see by. The world was becoming dark, not the darkness of night which passed every 24 hours, not the darkness of deep shadow which could be pierced by sunlight, but the darkness of a world in which the sun had become invisible, in which the light itself had been blocked out by a planetary pall of smoke and dust and ash. The temperature began to drop. The heat that had come from the returning ejecta, the heat of the broiler effect, began to fade as the particles settled and as the upper atmosphere began to cool. The radiation that normally arrived from the sun began to diminish. With the sun obscured, less light and less heat were reaching the surface. At first, the temperature changes might have been subtle, but within days the change would have become dramatic. Within weeks, the temperature would have dropped far below what any creature in the Cretaceous world had ever experienced. The world was entering what scientists call impact winter, a period of darkness and cold that would last for weeks, months, or perhaps even years, depending on how much material had been injected into the atmosphere and how quickly that material would settle out. But there was another catastrophe unfolding simultaneously, one that was invisible to the creatures experiencing it, one that would take much longer to show its effects, but one that would ultimately prove to be just as devastating as the darkness and the cold. The asteroid had struck into limestone and gypsum deposits, rocks that contained vast quantities of sulfur. When those rocks were vaporized by the impact, the sulfur was released into the atmosphere. Billions of tons of sulfur dioxide were injected into the upper atmosphere, into the stratosphere where the particles would remain for months or even years. This sulfur dioxide would undergo chemical reactions in the atmosphere, combining with water vapor to form sulfuric acid. And that sulfuric acid would rain down on the world as acid rain, a rain so acidic that it would burn the leaves of plants, that would acidify the soil, that would enter the oceans and acidify the waters there. This acid rain did not fall immediately. It took weeks and months for the sulfur dioxide to transform into sulfuric acid droplets, and for those droplets to begin falling. But when the rain did come, it was relentless. It fell not for a day or a week, but for months. For months the rain that fell from the sky was acidic, dangerous to plants, dangerous to animals, dangerous to the delicate chemistry of the oceans. The pH of the rain was probably around 3, comparable to vinegar, comparable to the most acidic rain that has ever been measured in the modern world. This rain, falling for months, began the slow process of destroying the vegetation that remained after the fires. It began to alter the chemistry of the soil. It began to change the oceans. The week following the impact was a period of absolute devastation. The darkness was nearly complete. In the daytime, it might have been possible to see a few feet in any direction, but the world had become twilight, had become dim, had become a place of shadows and reduced visibility. The temperature had dropped dramatically. The fires had died down, though some fires might have continued burning for weeks or months in isolated locations. The ash and dust continued to fall, continuing to darken the sky, continuing to alter the chemistry of the atmosphere. The acid rain continued to fall wherever water fell at all. The world had been transformed into a place utterly unlike the warm, bright, stable planet it had been before the impact. In the oceans, the changes were perhaps even more catastrophic than on land. The impact had created a wall of water, a mega tsunami that had raced across the Gulf of Mexico and beyond. This tsunami had been more than 300 feet high, a wave so large that it would have carried ocean water far inland, depositing salt water and sediment in the bodies of marine organisms across previously dry land. But the tsunami itself, catastrophic though it was perhaps not the most devastating change to ocean chemistry. As the days and weeks passed and the acidic rain fell into the oceans, the chemistry of the seawater began to change. The pH began to drop. The oceans, which had been slightly basic, became more neutral or even slightly acidic. This change might seem small, but it was catastrophic for the organisms living in the seas. The plankton that formed the base of the ocean food chain were sensitive to changes in ocean chemistry. As the pH of the ocean changed, as the acidity increased, many species of plankton died. The phytoplankton that produce oxygen through photosynthesis began to die as the light levels in the ocean dropped due to the ash and dust, blocking sunlight from reaching the water. Without these organisms, the oxygen levels in the ocean began to drop. The tiny creatures that form the foundation of the ocean food web began to disappear. And as they disappeared, the creatures that depended on them, the zooplankton, the small fish, the larger animals that fed on them, began to starve. The food chains that had been stable and productive for millions of years were collapsing. On land, the plants that the herbivores depended on were gone, burned or dying from acid rain, or unable to photosynthesize in the darkness. The herbivores, the great herds of Edmontosaurus, the Triceratops, the Iguanodon, and countless other species, were starving. Without herbivores, the carnivores that preyed on them were starving. On land and in the sea, the living world was beginning to fail. The pyramid of life, so carefully balanced, so finely tuned by millions of years of evolution, was collapsing. And it was collapsing everywhere, on every continent, in every ocean, all at the same time. This is the moment at which we should pause and consider something remarkable. All of this catastrophe, all of this devastation, all of this rearrangement of the living world had occurred in the first days and weeks after the impact. The full extinction, the death of 75% of all species on Earth, did not occur overnight, but it had begun. The mechanisms were in place. The darkness, the cold, the acid rain, the collapse of the food chains. These were all occurring within the first days of the impact, and they would continue. The darkness would persist for months or years. The cold would last for years. The acid rain would fall for months. And during all of that time, creatures were dying, starving, freezing, breathing toxic air, struggling to survive in a world that had suddenly become hostile to all life. And yet, it is also true that this was not the end of the story. In the slow, patient passage of geological time, the world would recover. The darkness would eventually lift, weeks and months and perhaps years after the impact, as the ash and dust settled from the atmosphere and began to accumulate on the ground. The acid rain would eventually stop falling as the sulfur dioxide was converted and fell to the surface. The temperatures would slowly rise again as the darkness lifted and the sun's warmth began to reach the surface of the planet once more. New plants would begin to grow in the devastated landscape. Seeds that had survived the catastrophe in the soil, spores that had drifted on the wind, roots that still lived in the darkness and the cold. New animals would evolve to fill the ecological niches left vacant by the extinctions, small creatures that would eventually give rise to new lineages, new families, new orders of life. It would take millions of years. It would be an unimaginably long time from a human perspective, a duration so vast that it would encompass the entire history of human civilization, and then multiply that by thousands. But from the perspective of deep time, from the perspective of geological processes that unfold slowly and patiently over the ages of the Earth, the recovery of the Earth from the impact catastrophe was relatively swift. The planet healed itself through the same processes that had allowed it to heal from countless other disasters in its 4.5 billion year history. Life persisted because life is resilient, because even in the most dire circumstances there are always some organisms that can survive. The world was remade, transformed into something new, something different from what had come before, but something alive and thriving nonetheless. And as you drift deeper into sleep, as the weight of deep time settles upon your consciousness like a comfortable blanket, consider that you are living in that remade world. You are part of that recovery. You are a child of that catastrophe, separated from it by 66 million years of evolutionary time, but connected to it nonetheless, descended from creatures that survived the darkness and the cold and the hunger of the impact winter. The extinction that killed the dinosaurs created the conditions for your existence. In a very real sense, the catastrophe that devastated the Cretaceous world was the greatest gift that life on Earth has ever received. The months and years that followed the impact were a time of slow, relentless transformation. The darkness that had descended upon the world in the first hours and days began to lift only gradually, as the finest particles of ash and dust began to settle out of the atmosphere and fall to the ground. But even as the visible darkness began to clear, other changes were unfolding, changes that were less obvious but ultimately even more consequential. The temperature, which had plummeted in the weeks following the impact, continued to drop. The impact winter that had begun as the dust filled the sky now deepened into a condition more severe than any winter that the Cretaceous world had ever experienced. Temperatures dropped by 15 to 25 degrees Celsius below normal, a catastrophic change for a world that had evolved under conditions of tropical warmth, for animals adapted to consistently warm conditions, for dinosaurs whose metabolisms had been calibrated for that warmth. The cold was deadly. But the cold was not the only problem. The darkness, even as it lifted slightly, prevented photosynthesis. Without light, plants could not photosynthesize. They could not convert sunlight and carbon dioxide into the sugars that fueled their growth. The plants that had survived the initial fires, that had persisted through the first terrible days of ashfall and acid rain, were now facing an entirely different catastrophe. They could not grow. They could not reproduce. They could not maintain themselves. They began to die, slowly, as their stored energy was consumed in the struggle for survival, as their reserves of nutrients were depleted. Day by day, plant by plant, forest by forest, the vegetation of the world began to disappear. The green that had covered the land for millions of years was fading. The world was becoming a place of brown and grey and black, the colours of ash and dead wood and bare earth. And as the plants died, the herbivores that depended on them began to starve. The great herds of Edmontosaurus, which had numbered in the thousands, began to diminish. The Triceratops, which had grazed in families, found themselves in a barren landscape with nothing to eat. The Iguanodon and the countless other species of plant-eating dinosaurs faced the same terrible choice: starve or try to migrate to places where there might still be vegetation. But there was nowhere to migrate to. The darkness was global. The cold was global. The devastation was planetary in scale. There was no refuge. There was no place where life had been spared. And one by one, the great herbivores began to die. Some died quickly, of starvation or cold. Others lingered, surviving for weeks or months on the last remnants of vegetation, growing weaker, becoming more vulnerable, until finally even they succumbed. As the herbivores died, the carnivores that had hunted them began to face the same slow starvation. The Tyrannosaurus rex, which had ruled the lands as the apex predator for millions of years, found that its food supply was evaporating. The smaller theropods that had hunted smaller prey faced the same empty landscape. For carnivores, there was perhaps even less hope than for herbivores. They were dependent on other animals for food, and if those animals were dying, then the carnivores would die as well. Within months, the great predators began to disappear. The Tyrannosaurus rex, that magnificent creature that had survived for millions of years, that had been the perfect hunting machine, that had evolved to fill a particular role in a particular ecosystem, it was gone. Not all at once, not in a single moment, but through the slow, relentless process of starvation in a world that could no longer support it. The age of the dinosaurs was ending, not with a bang, but with a slow diminishment, a gradual attenuation, a fading into extinction. The oceans presented a different picture, but one that was equally dire. The impact had created a tsunami that had devastated coastal ecosystems. The darkness had prevented photosynthesis in the upper layers of the ocean, where light normally penetrates and where the base of the ocean food chain exists. The plankton that formed the foundation of marine food webs had been decimated. Without plankton, without the tiny creatures that convert sunlight into organic matter, the entire marine food chain began to collapse. The fish that had fed on plankton began to starve. The larger marine reptiles that had hunted fish began to face a world in which their prey were vanishing. The mosasaurs, those great swimming reptiles that had dominated the oceans, found themselves in increasingly empty seas. The oceans, which had been rich with life, were becoming wastelands. The coral reefs, which had formed in tropical seas and which had been the centres of marine biodiversity, were dying, acidified by the sulfuric acid rain, stressed by the loss of their symbionts. The corals bleached and died. The reefs that had taken millions of years to build were destroyed in months. But not everything died. This is the remarkable thing, the thing that fills us with wonder when we contemplate it. Some creatures survived, some species persisted through the darkness and the cold and the hunger of the impact winter. In the oceans, some fish survived, some sharks survived, some mollusks survived, some turtles survived, though many species did not. The small crocodilians survived, their cold-blooded metabolism allowing them to slow their functions and require less food than the warm-blooded dinosaurs. Some birds survived, not the large flightless birds, but the small feathered dinosaurs, the creatures that we now call birds, which could fly, which could migrate, which could find shelter and food in the changing world. Some insects survived, in spite of their apparent vulnerability. Ants survived, beetles survived, cockroaches survived. Some plants survived as seeds or spores in the soil. Some small mammals survived, burrowing creatures that could hide in the earth, that could eat seeds and insects and whatever food they could find, that were small enough to require relatively little food to survive. These survivors became the foundation for a new world. In the years and decades and centuries following the impact, as the darkness lifted and the temperature gradually rose, as the acid rain stopped falling and the chemistry of the oceans began to return to normal, life began to recover. The first plants to colonize the devastated landscape were probably ferns and low-growing herbaceous plants, small plants that could grow quickly from spores and seeds, that didn't require the massive infrastructure that trees required. Slowly, over thousands of years, the forests began to re-establish themselves. New species of plants evolved, different from the species that had dominated the Cretaceous world. The flowering plants, which had been relatively new and not yet fully dominant in the late Cretaceous, became increasingly abundant in the new world that emerged from the catastrophe. The small mammals that had survived the extinction event, huddled in burrows while the world burned, began to diversify. They began to evolve new shapes and sizes, new adaptations, new ways of making a living in the recovering world. Within a few million years, they began to develop larger forms. Within 10 million years, there were mammals of remarkable diversity and size. Within 50 million years, the mammals had radiated into nearly all the ecological niches that the dinosaurs had once occupied. Some became plant-eaters as large and as diverse as the plant-eating dinosaurs had been. Some became meat-eaters and predators. Some took to the trees. Some returned to the oceans. The age of mammals had begun, and from those early mammals would eventually come primates, then apes, then humans. The extinction of the dinosaurs had created the conditions for the evolution of human beings. In a real sense, every human being who has ever lived, every thought that has ever been thought by a human mind, every work of art and music and literature that humanity has ever created, all of it existed because an asteroid fell 66 million years ago. But for a long time, no one knew that this was how the dinosaurs had died. The fossils of the dinosaurs, preserved in rock, showed that they had existed and then suddenly disappeared. But the cause was a mystery. The prevailing view among geologists and paleontologists for most of the 20th century was that the dinosaurs had gradually declined, that they had become outmoded, that they had been replaced by more advanced forms of life. The extinction was seen as the result of slow evolutionary processes, of competition from rising mammalian forms, of gradual environmental change. The idea that dinosaurs were failures, that they had been made obsolete by the passage of time, was deeply embedded in scientific thinking. It was only in 1980 that this view began to change. In 1980, a physicist named Luis Alvarez and his geologist son Walter Alvarez published a paper proposing a revolutionary idea. They suggested that the dinosaurs had not gradually declined into extinction. Instead, they suggested that the dinosaurs had died suddenly, killed by the impact of an asteroid or comet. The evidence for this was a thin layer of clay found in Italy and in other locations around the world. This clay layer marked the boundary between the Cretaceous period and the period that followed it, the boundary that is called the KPG boundary, or the Cretaceous-Paleogene boundary. The clay layer contained an unusually high concentration of iridium, a chemical element that is rare on Earth, deposited in the Earth's crust by geological processes over millions of years. but which is relatively common in asteroids and meteorites. The Alvarezes proposed that the high concentration of iridium in this clay layer was evidence that it had been deposited by the impact of an asteroid. The asteroid had spread iridium-rich material all around the globe. That material had settled and accumulated, creating a thin but distinctive layer of clay enriched with iridium. The initial reaction to the Alvarez hypothesis was skepticism. Many geologists rejected the idea. It seemed too sudden, too catastrophic, too unlike the slow, gradual processes that geologists had come to emphasize in their understanding of the Earth's history. The doctrine of uniformitarianism, the idea that the present is the key to the past, that slow, steady processes were the primary drivers of geological change, had become deeply embedded in geological thinking. A catastrophic impact seemed to violate this principle. The idea was widely criticized. It was called radical, speculative, not sufficiently grounded in evidence. The paleontologists were equally skeptical. The idea of a sudden extinction seemed to contradict the fossil record as they understood it. If the dinosaurs had been killed suddenly, shouldn't there be a sharp boundary between layers containing dinosaur fossils and layers that didn't? But the fossil record was less clear than that. Fossils were rare. The layers containing fossils were often separated by significant gaps in the rock record. It was easy to argue that the fossil record showed a gradual decline rather than a sudden extinction. But as time passed, more evidence accumulated. Other scientists began to search for the iridium layer, the KPG boundary clay, in other places around the world. And they found it. Everywhere. On every continent, wherever rocks of the right age were exposed, scientists found the characteristic thin layer of clay enriched with iridium. The layer was there in North America, in Europe, in Asia, in South America, in Africa, in Antarctica. The distribution was global, supporting the idea of a global catastrophe. Furthermore, other evidence began to accumulate. Scientists found shocked quartz crystals that had been fractured and deformed by the tremendous pressure of the impact. These shocked quartz grains were found in the KPG boundary layer in many places. Scientists found tektites, small glassy spherules created by the melting of rock during a high-impact event. These had been preserved in the rocks of the boundary layer. The evidence for the impact hypothesis continued to build, layer upon layer, like the geological record itself. Yet even as this evidence accumulated, there was still a missing piece. Scientists had found the evidence for the impact, the iridium, the shocked quartz, the tektites, the KPG boundary layer distributed across the globe, but they had not found the crater. Where was the asteroid impact site? Where was the crater that would have been created by such a massive impact? For nearly a decade, the impact crater remained a mystery. The Alvarez hypothesis was supported by evidence, but without finding the crater itself, it remained somewhat incomplete, somewhat lacking the final confirmation that a direct discovery would provide. The crater was finally discovered in 1991, more than a decade after the Alvarez hypothesis had been proposed. It was found beneath the surface of the Yucatan Peninsula in Mexico, buried beneath layers of sediment and rock that had accumulated since the impact. The crater was enormous, about 180 kilometers in diameter, with a central peak structure that rose above the surrounding floor. The crater was named Chicxulub, after a small town near the impact site. And when geologists examined the rocks of the Chicxulub crater, they found confirmatory evidence of everything the impact hypothesis had predicted. They found shocked quartz. They found melted rock. They found evidence of the tremendous pressures and temperatures that could only have been created by an impact event of truly catastrophic proportions. The discovery of the Chicxulub crater provided the final, decisive confirmation of the impact hypothesis. The dinosaurs had been killed by an asteroid impact. There was no longer any doubt. The acceptance of the impact hypothesis marked a major shift in geological and paleontological thinking. It showed that catastrophic events that happened suddenly, dramatically, violently, could be as important in shaping the Earth's history as the slow, gradual processes that geologists had emphasized for so long. It showed that the history of the Earth was not simply a story of gradual change and slow accumulation. It was also a story of dramatic interventions, of sudden catastrophes, of moments when the slow passage of time was interrupted by events of overwhelming power. And it provided a new context for understanding extinction. Extinction was not necessarily a sign of failure or of evolutionary obsolescence. It could be the result of a sudden environmental catastrophe, a change so dramatic and so overwhelming that even the most successful and well-adapted creatures could not survive it. 66 million years have passed since the asteroid fell. The crater it created has been buried beneath new layers of rock. The landscapes that were devastated by fire and darkness and cold have recovered completely. New oceans have formed, new mountains have risen, new species have evolved to fill every ecological niche, every possible way of life. The birds that descended from the small dinosaurs that survived the impact have diversified into thousands of species. The mammals that huddled in burrows while the world burned have become the dominant land animals. And from one group of those mammals, the primates, there evolved beings with minds capable of understanding their own history, capable of peering back through the depths of deep time, capable of reconstructing the moment of impact with remarkable accuracy. We humans are the latest chapter in the story of recovery, the latest evolutionary development in a lineage that extends back to those small burrowing creatures that survived the catastrophe. As you rest now, as sleep draws you deeper and deeper into its gentle embrace, you might reflect on this story. The Chicxulub impact, the extinction of the dinosaurs, the devastation and recovery of the living world. It is a story of catastrophe and resilience, of loss and renewal. It is a story written in the rocks beneath our feet, deciphered by patient scientists, illuminated by evidence that has been preserved for millions of years, and it is a story that reminds us that even the most complete and final-seeming endings are not truly final. They are transitions. They are transformations. The world that emerged from the impact catastrophe was different from the world that existed before it, but it was still a world full of life, full of possibility, full of the fundamental drive of living things to persist, to adapt, to diversify, to fill every available niche with form and function and being. In the darkness of impact winter, seeds waited in the soil. In the cold and the hunger, small creatures endured in their burrows. Through extinction came the possibility of new forms, new directions, new pathways for life to explore. And millions of years later, in the sunlight of a new day, on a planet that had been remade by catastrophe, but that had healed and recovered and flourished, consciousness emerged. Mind came into being, and that mind was able to look backward through time, to understand its own origins, to know that its existence was built upon the foundation of catastrophe and recovery. Sleep well, knowing that you are part of this vast story. You are a descendant of survival. You are an heir to the resilience of life. You are living proof that from the greatest catastrophes can come the most remarkable recoveries. The world has been broken and mended before. It will recover from what comes next, as it has recovered from what came before, and you, in your small moment of existence, in your brief time of consciousness, are connected to that vast journey. You are made of stardust, quite literally made of the elements created in the hearts of dying stars. And now, as you drift deeper into sleep, as consciousness begins to fade like the light fading from the Cretaceous sky, remember that the recovery of the world began in darkness. Rest now in that darkness, in that safe and gentle place where consciousness dissolves into dreams. The world will still be here when you wake. Life will continue its long and patient journey, and you will be part of that journey tomorrow and all the days that follow, descendant of asteroids and extinction, child of recovery, inheritor of a world that learned to live again after the worst catastrophe imaginable. The search for the Chicxulub crater began not with seismic equipment or satellite imaging, but with puzzlement. The Alvarez hypothesis, proposed in 1980, suggested that an asteroid had ended the Cretaceous period, yet for over a decade after that revelation no one had found the actual scar. Scientists combed through geological records, following breadcrumbs of iridium and shocked quartz, looking for the point of impact. Somewhere on Earth, they reasoned, a crater nearly 200 kilometers wide should have been unmistakable, and yet it remained hidden, as if the planet itself wanted to keep this secret buried beneath layers of time and sediment. The mystery deepened rather than resolved. If an asteroid had struck, where was the evidence? Where was the wound in the Earth's crust? In 1978, before the Alvarez hypothesis was even published, a geophysicist named Glenn Penfield was working for Pemex, the Mexican oil company, studying the subsurface geology of the Yucatan Peninsula. His work involved analyzing gravity data, maps of invisible forces pulling at the Earth's surface, patterns that revealed hidden structures far below the reach of the eye. These gravity measurements could sense what nothing else could sense, could perceive disturbances in the Earth's mass that indicated buried geological features. Penfield spent his days examining numbers, plotting measurements, watching patterns emerge from seemingly random data. As he studied the gravitational readings from beneath the Yucatan, something extraordinary began to appear. A vast circular anomaly, a ring of unusual gravitational values arranged in a nearly perfect circle. The data showed what Penfield, trained to read these invisible messages, recognized immediately. A massive depression in the Earth's crust, an enormous bowl carved into the bedrock by some cataclysmic event. The crater was nearly 200 kilometers in diameter, absolutely colossal, a structure that would have required unimaginable forces to create. At the time, Penfield had no way to know this was the crater everyone would soon be searching for. At the time, he was simply a scientist noticing something unusual in the data, a pattern that demanded explanation, an anomaly that refused to fit into conventional understanding. When Penfield presented his findings in 1981, the scientific community did not embrace them with enthusiasm. His work was published but largely overlooked, filing away into journals that few read. The gravity anomaly existed, certainly. The data was clear and reproducible. But what did it mean? Was it an impact crater? Was it ancient? Was it the asteroid impact crater everyone was beginning to discuss? Or was it something else entirely, some geological feature that had nothing to do with the extinction of dinosaurs? The professional equivalent of silence greeted his discovery, that curious quiet that follows when a finding doesn't quite fit into the accepted narrative, when evidence appears but its meaning remains uncertain. Penfield had stumbled upon perhaps the greatest cosmic catastrophe in Earth's modern history, yet watched as his findings slipped into relative obscurity. Other scientists would need to rediscover what he had already found, following different paths through the darkness of time. In the late 1980s, more than a decade after Penfield's initial discovery, and nearly a decade after the Alvarez hypothesis had begun to reshape our understanding of extinction, a Canadian geologist named Alan Hildebrand began pursuing the same question with fresh eyes. Hildebrand examined the distribution of shocked quartz in sediments from the Cretaceous-Paleogene boundary, the layer in Earth's rocks that marked the precise moment of extinction, a boundary as real as a line drawn through time itself. Shocked quartz is quartz that has been subjected to impacts, pressure so extreme that the crystal structure becomes deformed, becomes uniquely altered in ways that only extreme impacts produce. By measuring the concentrations of shocked quartz across different parts of the world, Hildebrand could create a map of the impact's influence. And as he studied this distribution, a pattern emerged. The concentration was highest in the Yucatan Peninsula. The shocked quartz radiated outward from Mexico like a pattern of concentric circles, strongest in that particular region, which could only mean one thing. The impact had occurred directly beneath or very near the Yucatan. Hildebrand's independent research, conducted years after Penfield's work, was leading him to the same conclusion through different pathways, using different evidence. Science often works this way. The truth, waiting beneath the surface, eventually forces itself upward through multiple routes, multiple lines of inquiry all converging toward the same inescapable reality. In 1990, when Hildebrand and Penfield connected and compared their findings, the confirmation was complete. The Chicxulub crater, the name derived from a nearby Mayan village meaning the tail of the devil, was real. It was buried beneath the Yucatan, beneath 66 million years of accumulated limestone and sediment, but it was undeniably there. The crater measured approximately 110 miles in diameter, roughly 180 kilometers across the full expanse of its rim, a circle of destruction so vast that it would have taken hours for the initial shockwave to reach its far edge. It was one of the largest impact structures in the entire solar system, comparable to the great craters visible on the Moon's surface, on Mercury, on Mars, each one a monument to the violent history of worlds colliding with space. Now, finally, the collision that had haunted Earth past was no longer theoretical, no longer speculative. It had a location. It had a name. It had dimensions that could be measured and contemplated, that could be understood through the ordinary tools of science. The crater itself, hidden as it was beneath limestone, revealed itself in the most elegant way, through the landscape it had shaped, through the water that gathered in its boundaries. The rim of the crater, the boundary where the asteroid had excavated the Earth and created a depression in the bedrock, had persisted through the ages like a scar that never quite heals completely. And where depressions allowed water to collect, the Yucatan's permeable limestone created sinkholes, called cenotes, blue-green portals into the fresh water beneath, windows into coolness and depth. These cenotes formed a nearly perfect ring around the Chicxulub crater, a circle of waterholes marking the impact site's perimeter, as if the Earth itself had drawn a circle to commemorate the event, to remember what had happened here. What had seemed like a random scattering of natural wonders across the Yucatan landscape was actually a geological fingerprint, the signature of an ancient catastrophe written in water and stone. The cenotes are not randomly distributed. They form a visible arc, a geometric pattern that reveals the crater's presence to anyone who cares to see it, to anyone who knows the story. A tourist floating in one of these cenotes on a warm afternoon, surrounded by jungle growth and the calls of birds, unaware of the significance beneath them, would be swimming in a crater formed by an asteroid strike, resting in the calm waters that mark the boundary between two worlds, the Cretaceous and the Paleogene, the world of dinosaurs and the world that followed. The cenote water is remarkably clear, filtered through millions of years of limestone, so clear that you can see deep into its depths, can sense the coolness rising from below, can feel the presence of ancient water and ancient time. Some cenotes are hundreds of feet deep, their bottoms never fully explored, their depths containing secrets that even modern science has only begun to understand. The Mayan people, who lived in this region for thousands of years, regarded the cenotes as sacred portals to the underworld, as gateways to the spiritual realm. They could not have known that their sacred places marked a scar from the heavens, that every cenote they discovered and revered was part of the crater's ancient fingerprint. In 2016, scientists undertook an ambitious expedition to drill directly into the crater's peak ring. That ring of mountains formed when the impact's tremendous force caused rock to rebound upward, creating a temporary cavity that then collapsed into a ring of elevated peaks. These peaks were the crater's interior monument, formed by forces so enormous that they operate normally only at the moment of cosmic collision, when the rules of Earth's ordinary physics are temporarily suspended. The drilling team, working from a research vessel on the Campeche bank off Mexico's coast, faced technical challenges that would have seemed impossible just years before. The ocean above the drill site was more than half a kilometre deep. Below that lay hundreds of metres of sediment. Below that lay the limestone layers. And only then, reaching down more than a kilometre from the surface of the sea, would they find the rocks that had been most deeply affected by the impact itself. The drilling process was a marvel of precision engineering and patience. The drill bit, rotating against the ancient stone, advanced slowly, carefully, bringing up core samples from depths that had not been exposed to light since the age of dinosaurs. Each section of core that emerged from the borehole told a story, revealed a moment in time, preserved evidence of the catastrophe in physical form. The team worked in shifts, round the clock, driven by the knowledge that they were about to confirm or refute the models that had been built and rebuilt over decades. The penetration reached depths of more than 1,000 metres, going down through the limestone that had covered the crater for 66 million years, finally reaching the rocks that had been most deeply affected by the impact itself, the rocks that had been at ground zero when the asteroid arrived. What emerged from the bore cores astonished the scientists and confirmed their decades-old predictions, with vivid, physical evidence that could be held in the hand and studied under the microscope, evidence that transformed theory into certainty. The cores revealed granite that should have been buried several miles below the surface, lying in the cool darkness deep within the Earth's crust where sunlight will never penetrate. Yet this granite now lay at relatively shallow depths, near the surface in geological terms, brought upward from the depths by the terrible violence of that moment. The granite had been yanked upward in minutes, perhaps in seconds, by the sheer force of the explosion, pulled toward the sky by forces that would never come again, forces that only visit Earth once every hundreds of millions of years. Think about what this means. Rock that was miles below the surface, that had been undisturbed for millions of years, that would normally require millions of additional years of uplift and erosion to reach daylight, was instead transported upward almost instantaneously. The rocks, when subjected to such unimaginable pressure and heat, pressures millions of times greater than the pressure at the bottom of the ocean, Heat approaching that of the sun's surface had behaved not like solid material but like something fluid, like water or molten lava responding to enormous pressure, flowing in response to the impact's shockwaves. The scientists studying the cores could see the evidence of this transformation preserved in the stone itself. Minerals crushed and distorted, recrystallized in new forms, deformed in ways that only occur during extreme impacts. There was no ambiguity in what they were examining. The rock had been broken and reforged, its atomic structure altered, its very nature changed in the instant of the asteroid's arrival. You could hold a piece of core in your hand and feel the evidence of that moment, could sense the transformation that had been preserved in mineral form, could understand at a visceral level what had happened here when the world changed forever. The granite glittered under examination lights, its minerals catching light in ways they had not caught light since the day it was formed millions of years before the asteroid ever arrived. But perhaps most crucial was what the scientists did not find in those cores. The rock layers at Chicxulub were known to be rich in sulfur-bearing minerals, evaporates that formed in ancient seas, that should have been present in abundance if they had not been disturbed. Yet the drill cores showed that this sulfur had vanished entirely. Where chemistry said there should be sulfur, there was emptiness, a gap in the expected pattern, an absence that spoke volumes. The sulfur had been vaporized, transformed from solid crystal into a gas by the impact's heat, and launched high into the atmosphere in the first minutes after collision. This absence was its own profound presence, a negative space that confirmed what the models had predicted decades earlier. The sulfur had not simply melted or transformed. It had been annihilated, converted from solid matter into vapor, and scattered across the planet like an invisible shroud. Scientists called this the sulfur winter hypothesis, a term that captures both the mechanism and its consequence with elegant simplicity. The theory went like this. While the dust from the impact blocked the sun for days or weeks, creating immediate darkness, it was the sulfur aerosols that caused the prolonged cooling lasting years, perhaps many years, perhaps a decade or more. Sulfur dioxide and sulfuric acid formed a haze in the stratosphere, a chemical veil so dense that it blocked additional sunlight and reflected heat back into space, creating a blanket effect that worked in reverse, trapping cold instead of warmth. The world grew dark and colder, day after day, week after week. The sun would have been visible only as a dim orange disk through the sulfur haze, providing little warmth. Temperatures would have dropped rapidly, perhaps within weeks or months, by 30 or 40 degrees or more. Snow might have fallen in the tropics. The dinosaurs did not die from the impact itself, which was instantaneous and localized, affecting primarily the region near the Yucatan. They died from what came after, from months of darkness, from the slow choking of the atmosphere, from the cold that settled like a weight upon the world, from the failure of food chains as plants died, as herbivores starved, as predators found no prey. The sulfur, absent from the Chicxulub cores where it should have been plentiful, was the missing piece that proved the entire catastrophe, that transformed the hypothesis from compelling theory into established fact. The gap in the rock record was eloquent testimony to what had happened, speaking clearly about processes that had operated 66 million years before any human ever existed. The cores also contained another treasure, shocked quartz recovered from the peak ring itself, the very type of quartz that Hildebrand had used to trace the impact location. But this quartz was far more extreme, transformed to a degree rarely seen, melted almost beyond recognition. The quartz in the peak ring had endured the greatest pressures, the fiercest temperatures, the most intense transformation. It bore witness to the moment of impact in its very structure, preserved that terrible moment in its crystalline memory. And around these shocked minerals the scientists found layers of pulverized rock, of impact breccia, a fragmented, jumbled mixture of rock types that had been broken and mixed together by the force of collision. The layering and composition of this breccia told the story of the impact in geological language, a narrative written in stone. Here at the Calm Archive, we find ourselves grateful for the scientists who pursued this mystery with patience and precision across decades, who connected the dots and found the crater hidden beneath the jungle, who drilled into the Earth's crust to recover the evidence of what had been lost and transformed. We find ourselves marvelling at the crater itself, still healing after 66 million years, now a source of beauty and wonder rather than destruction. We marvel that the same technology that allowed us to measure gravity from the air, to drill deep into the earth, to read the secrets written in rocks could piece together a story that happened when the world was fundamentally different, when the sky was full of fire and the earth trembled. The scientists who found Chicxulub were not seeking glory or fame. They were simply following evidence wherever it led, trusting that the truth existed and could be discovered through observation and reason. Their work transformed our understanding of extinction, of catastrophe, of the way the world actually works on geological timescales. If you're still awake and enjoying this journey through deep time, we invite you to consider subscribing to the Calm Archive. Alec really does help more people find these videos when they can't sleep, when they're searching for something that feels vast and true and grounding. These videos reach thousands of people each night, each person lying in the dark, each person seeking the same comfort found in ancient history, in the slow turning of geological time. Now let us return together to the crater and follow what happened in the long aftermath of that terrible, magnificent day. In the years immediately following the impact, the world inhabited by the dinosaurs had become uninhabitable for the most part. The landscape was transformed beyond recognition. Forests had burned in the heat pulse that travelled outward from the Yucatan like an invisible wave of thermal radiation. Vast expanses of woodland charred and blackened, reduced to ash and charcoal. The wildfires ignited across the globe, continent after continent erupting in flame, forests that had stood for millions of years consumed in days or weeks. The ash rose into the atmosphere in enormous quantities, blocking the sun for months, creating a darkness so complete that it would have been impossible to see your hand in front of your face at noon. The oceans had been scoured by the impact wave, the tsunamis radiating outward from the impact site at the speed of sound, drowning coastlines and dragging them back down into deeper water, leaving nothing alive in the shallow seas that had been so full of life. The creatures that had dominated the Earth for 160 million years, the great dinosaurs that had walked and flown and swum through the Cretaceous world, were mostly gone in the first days and weeks after the impact. The few that survived the initial catastrophe faced a world of unimaginable harshness, darkness that would not lift, cold that cut through bone, starvation, as food chains collapsed and died, the end of everything they had evolved to survive within. Yet within this devastated landscape, life persisted in the most humble forms. In caves and burrows deep beneath the ground, small mammals huddled in the darkness, sheltered from the heat and ash above. In seeds buried in the soil and in spore colonies in the mud, plants waited in a state of dormancy, waited for conditions to change, waited with the patience of things that are not conscious, but are nonetheless perfectly adapted to survive. Life is patient beyond human comprehension. Life had been tested before across deep time and had endured. Life would endure again. The recovery began almost immediately in geological terms, though from the perspective of individual organisms it would have seemed impossibly slow. In the first years after the impact, as the dust began to settle and sunlight began to penetrate the haze, one type of plant colonized the blackened landscape: ferns. Ferns reproduce through spores, tiny airborne structures that can survive harsh conditions and spread rapidly on the wind. The fern spores had survived the impact, had remained dormant in the soil, waiting for conditions favourable enough for germination. As the ash settled and the temperature began to rise slightly as the darkness began to lift, the ferns germinated and grew. They spread rapidly across the devastated landscape, transforming the ash-covered ground into a simple green covering, a monochromatic forest of ferns where once had stood the diverse, complex forests of the Cretaceous. Scientists who study the rocks of this period can see this in the fossil record, a layer of rock called the fern spike, where fern spores become incredibly abundant in the sediments, where the plant record shifts from diverse forests to a simple, fern-dominated ecosystem. The fern spike is a visible sign of recovery, a mark of how life reasserted itself after catastrophe. The ferns were not the most complex or beautiful plants, but they were resilient. They asked only for light and moisture and time. They received all three. As the ferns began to cover the landscape and to produce oxygen through photosynthesis, the atmosphere began to change. Green was returning to the world. The sun-blocking dust continued to fall and settle, gradually clearing the skies, grain by grain, particle by particle, the darkness slowly lifting like a slowly awakening dawn. The world grew slightly warmer, slightly brighter, each day marginally better than the day before. Within months, the immediate darkness began to lift. Within a few years, recognizable day-night cycles had returned, the sun visible once more, providing warmth and light. The small mammals that had sheltered in burrows, that had survived on stored food and insects and worms, began to emerge into this transformed world. They ventured cautiously at first, perhaps, not knowing if the darkness would return, not knowing if this improvement was permanent. But as days turned to weeks, and weeks turned to months, the animals that had sheltered began to stay above ground longer. They began to explore this new world. They found a world with no large predators, no dinosaurs to hunt them, no large herbivores to compete with them for the plant matter. The dinosaurs had been perfectly adapted to their ecological roles, but once they were gone, those roles became vacant, available for other animals to fill. For the first time in their evolutionary history, stretching back 160 million years, small mammals had access to ecological resources that had always been denied to them. For 160 million years, mammals had been confined to the shadows, living small, living quietly, living in the darkness of the dinosaur age. Now that age had ended, and the mammals could begin their own story. The radiation of mammals in the early Paleogene period was rapid and dramatic in geological terms, a burst of evolution that filled empty niches, that explored possibilities that had been closed during the dinosaur age. Within 300,000 years of the impact, a mere instant in geological terms, yet an eternity in evolutionary terms, millions of generations, new mammalian species were appearing at extraordinary rates. Fossils from this period show an explosion of diversity. New insectivores hunting small creatures in the undergrowth, new herbivores feeding on plants, new carnivores, each exploiting some aspect of the new world, each filling a role that had been unavailable before. Some mammals grew large, reaching sizes that their Cretaceous ancestors had never approached. Some remained small and specialized. The mammals were evolving rapidly, developing new body forms suited to new environmental conditions, new adaptations for new ways of life, new ways of being in the world. This was the beginning of the age of mammals, the Cenozoic era, the time that would eventually lead to primates, to humans, to you lying here in the darkness listening to the story of the world's transformation. This was the age that began with fire and ash and cold, yet led ultimately to warmth and community and consciousness. And it all began with a single moment, with the arrival of a rock from space and the cascade of consequences that followed. Without the asteroid, it is reasonable to assume that dinosaurs would still dominate the Earth. The dinosaurs had evolved successfully for 160 million years, producing an incredible diversity of species and body forms, adapting to every ecological niche. They had shown no sign of declining, no sign of failing. There was nothing inevitable about their departure from the Earth. They might have continued to evolve and diversify for millions of years more, adapting to climate change, adapting to environmental shifts, developing new species and new forms. The mammals would have remained small and nocturnal, confined to burrows and caves, never given the opportunity to expand and develop into new forms. Primates might never have evolved. Humans might never have appeared. You would not be here listening to this story. The entire trajectory of Earth's history, and of your existence, depended on a rock from space arriving at precisely the right angle, at the right location, at the right moment. The asteroid's trajectory brought it to the Yucatan on a June afternoon 66 million years ago, but the trajectory was not random. It was determined by the gravity of the Sun, of Jupiter, of Mars, of countless other planets and asteroids and distant stars, all pulling slightly on this small piece of rock drifting through space. If it had arrived a few hours earlier or later, it would have hit the Atlantic Ocean instead, and the impact would have been different. If it had struck the Earth 6 hours earlier in its orbital rotation, it would have hit a different location entirely, and the catastrophe would have unfolded differently. The impact depended on a series of cosmic accidents, on probabilities so small that they seem almost impossible, yet they occurred. The universe is large enough, the cosmos old enough, that improbable events do eventually occur, and when they do, they reshape everything. The irony of extinction is profound and inescapable. The worst day in Earth's history, the day that erased 90% of all species, was simultaneously the day that made human existence possible. The asteroid that killed the dinosaurs created us. This is not something to celebrate precisely, but something to contemplate, to hold in mind as a kind of paradox. Catastrophe and creation are not opposites in the long view of Earth's history. They are intertwined. The same asteroid that was death to Triceratops and Tyrannosaurus rex was the beginning of the path that would lead to humanity. This does not justify the extinction or diminish its terrible meaning for the creatures that lived through it. It simply reflects the way the Earth works on deep time. Nothing is stable, nothing is permanent. The only constant is change. The oceans recovered more slowly than the land. The complex ecosystems of the Cretaceous seas, the coral reefs, the ammonites, the ancient fish, had been devastated. The corals were particularly affected by the impact's aftermath. Corals are sensitive to temperature changes and light. With the sun blocked by dust and the sulfur haze, with the temperature dropping, with the food chains collapsing, the corals died. The reef ecosystems collapsed entirely. For millions of years there were no coral reefs on Earth. The corals would eventually recover, would eventually rebuild their colonies and their complex associations with other organisms, but this process took millions of years. Modern coral reefs, the ones you might visit in tropical waters today, did not become established until millions of years after the impact. The recovery of the oceans was a slow process of rebuilding, of allowing life forms to adapt to changing conditions, of waiting for environmental stability to return. The oceans that had once been so full of complex life had to be repopulated gradually, through the reproduction and migration of the survivors. New species of fish evolved, new kinds of mollusks appeared, new organisms adapted to the shallow seas and deep trenches. The transition took millions of years, a long slow process of ecological reconstruction that we can read in the rocks if we know how to look. New ecosystems formed in the wake of the impact, ecosystems fundamentally different from the ones that had existed before. Grasslands appeared on the continents for the first time, or at least became common and widespread for the first time. The flowering plants, which had been relatively minor and restricted during the Cretaceous, diversified rapidly in the Paleogene, taking advantage of new opportunities. The world began to look more like the world we know today, with flowering trees and grasses and herbs covering the land, with new insects to pollinate them, with new birds to feed on the insects. The birds, it is important to remember, are living dinosaurs. They are not descended from dinosaurs. They are dinosaurs, survivors of the Cretaceous who adapted to the new world. The birds survived the impact, and in the post-impact world they diversified and filled many of the ecological roles left empty by the extinction of non-avian dinosaurs. New bird families emerged and established themselves, the hawks and eagles soaring on thermals, the songbirds filling the morning with their calls, the owls hunting under the stars, the penguins diving deep into the cold ocean. The lineage of the dinosaurs continued, but it continued in smaller forms, in new shapes, in new ecological niches. If you hear a songbird singing at dawn, if you watch a raptor circling overhead, if you see a penguin diving into the sea, you're observing the living descendants of the dinosaurs. The extinction did not end the dinosaur lineage. It merely reshaped it, constrained it to new forms, and gave it new opportunities for evolution and diversification. The mammals continued their rapid evolution through the Paleogene period. Within a few million years, mammals had achieved a diversity and complexity that they had never approached during the age of dinosaurs. New orders emerged. The primates, small and adaptable, grasping at branches, the carnivores, predators to fill the niches of the great theropods, the ungulates, fleet-footed herbivores, the cetaceans returning to the oceans as whales and dolphins. The mammals that had once been confined to ecological niches too small and marginal to notice were now filling the largest and most prominent roles in terrestrial and marine ecosystems. Some grew large, developing body sizes and ecological complexity that competed with or exceeded the dinosaurs' previous roles. Some remained small and specialized, finding success in niche environments. The diversification of mammals is one of the most dramatic chapters in evolutionary history, a burst of speciation and adaptation that would ultimately lead to all the mammals alive today, from the smallest shrew to the largest whale, from the bat-like creatures of the night to the primates swinging through trees. This included ultimately the primates, and the primates would eventually lead to humans, to consciousness, to language, to the ability to contemplate these ancient events. The entire story of mammalian evolution, and therefore the entire story of human existence, began with that asteroid impact 66 million years ago. The environment of the early Paleogene gradually stabilized through the millions of years that followed. The dust settled slowly, grain by grain, falling through the atmosphere, accumulating on the ground. The sulfur began to precipitate out of the atmosphere, forming acid rain that would have been harsh, but that also carried sulfur compounds back to the Earth, where they could be recycled. The temperature began to normalize, rising gradually as the sulfuric haze dispersed. The darkness lifted. Within a decade or two, the worst of the impact's immediate effects had passed, though the recovery was just beginning. Life adapted to the new conditions. Ecosystems reformed from the survivors and the rapidly evolving new species. New species evolved to fill the gaps left by extinction, found new ways of living, exploited new resources. This process took millions of years for full recovery, but in geological terms the world bounced back with remarkable speed, considering the magnitude of the catastrophe. Limestone deposits from the earliest part of the Paleogene show signs of reef growth beginning again, the first tendrils of the new reef ecosystems that would eventually match the complexity of what had come before, eventually creating coral gardens as vibrant as the Cretaceous reefs had been. The fossil record shows a gradual diversification of life, a slow increase in complexity, a patient reconstruction of the ecosystem from the ground up, layer by layer, species by species. The ferns did not remain dominant for long. Within a few million years, flowering plants had begun to reassert themselves, spreading across the land. Within a few million years more, recognizable modern plant families had appeared, including the grasses and the hardwood trees we know today. The recovery was real and measurable, visible in the rocks and in the fossils they contained, a story written in stone that scientists can still read today. Here at the Calm Archive, we are grateful for the opportunity to contemplate this recovery, this resilience, this capacity of life itself to endure and transform in the face of catastrophe. The recovery of life after the Chicxulub impact teaches us something profound about the nature of life itself, its flexibility, its adaptability, its capacity to find new forms and new expressions even in the wake of devastation. Life does not give up. Life does not surrender to circumstance. Life finds a way. If the Calm Archive has become part of your bedtime routine, I would love it if you shared this video with someone who might need it tonight. Someone who lies awake wondering about the deep structure of the world, someone seeking comfort in the knowledge that life persists, that ecosystems recover, that the Earth continues its slow and patient turning, that catastrophe can be overcome, and if you haven't subscribed already, hit that subscribe button. We upload new videos every day, each one exploring some aspect of the deep past, some element of Earth's incredible history, each one crafted to help you rest and drift towards sleep. Now, let us continue together into the space where recovery becomes security, where healing becomes stability, where the world we live in today takes its final shape. As we contemplate the Chicxulub impact and the terrible catastrophe it caused 66 million years ago, a question naturally arises in the mind. Could it happen again? Could another asteroid strike Earth? Could another catastrophe of that magnitude occur in our time or in the time of our descendants? The asteroid that killed the dinosaurs was not unique. It was not a singular, unprecedented event. Asteroids and comets cross the Earth's orbit constantly, moving through space in patterns determined by gravity, by the mechanical laws that govern the cosmos, by the initial conditions of the solar system billions of years ago. The Earth sits in a cosmic neighborhood where collisions have occurred and will occur again. The solar system is not a peaceful place. It is dynamic, active, filled with moving bodies whose paths sometimes intersect. Scientists have given a name to these objects that pose potential risks: near-Earth objects, or NEOs. These are asteroids, comets, and other bodies whose orbits bring them close to Earth's position in the solar system, whose trajectories take them within a certain distance of our world. Some pass near enough that they could potentially strike the planet. Some will eventually do so. The question is not whether another impact will occur, but when, in how many millions of years, in what era, under what circumstances. NASA and other space agencies around the world have undertaken the important responsibility of tracking these near-Earth objects. Thousands have been catalogued and their orbits calculated with precision. Their trajectories are plotted far into the future, their paths predicted using the physics of celestial mechanics, using the same equations that describe gravity and motion that have worked since Newton. Scientists monitor these objects carefully, watching for any that might show a trajectory leading to Earth in the centuries and millennia ahead. Most of the catalogued asteroids will miss Earth for millions of years, their orbits taking them safely through space, never coming close enough to pose a danger. But the monitoring continues regardless. The databases grow larger with each passing year. The catalogue becomes more complete as new detection technology is developed and deployed. Yet this safety, this careful tracking and monitoring is relatively recent. For most of human history, humans had no awareness of the danger. We lived ignorant of the asteroid belts, unaware of the comets in deep space, unaware that we inhabited a planet in a cosmic shooting gallery. We had no idea how fragile our world was, how it had been struck before, how it would be struck again. The knowledge of the danger is only now becoming part of human consciousness. In 2013, something occurred that illustrates both the danger and the limitations of our knowledge. A meteor struck Earth's atmosphere above Chelyabinsk, Russia, a city of over 1 million people living their daily lives, unaware of what was about to happen. The meteor was relatively small, only 20 meters in diameter, roughly the size of a building, certainly not large by cosmic standards. But when it struck the atmosphere at high speed, travelling at over 20 kilometers per second, thousands of times faster than a commercial airliner, it exploded with tremendous force. The explosion occurred several kilometers above the ground, yet the force was immense. The explosion was more powerful than a nuclear bomb, with the force equivalent to 15 nuclear weapons. The blast wave that descended from that explosion flattened forests and broke windows across the city, sending shock waves through the air that injured 1,500 people. Thousands more might have been killed if the explosion had occurred directly over the city instead of above it. Some of those injured were in hospitals, some in schools, some in their homes going about their daily lives. The remarkable and sobering thing about the Chelyabinsk event was that it came completely as a surprise. Nobody had seen this asteroid coming. The meteoroid approached from the direction of the Sun, which made it nearly impossible to detect with telescopes from Earth. Scientists did not know it was there until it was too late to do anything about it. The meteoroid was already in Earth's atmosphere, already descending, already about to explode. A larger asteroid hitting Earth today could devastate a city or an entire region. A Chicxulub-sized asteroid would still cause global catastrophe. Another event from more distant history illustrates the size of the threat even more dramatically. In 1908, an explosion occurred over Siberia, in an area called Tunguska, in a remote, sparsely populated region of Russia. The explosion flattened 80,000 square miles of forest, an area roughly the size of Massachusetts, destroying trees and vegetation over an enormous area. The trees fell all in the same direction, radiating outward from the impact point, their orientation showing the direction of the blast wave's force. The explosion was caused by an asteroid estimated to be between 50 and 80 meters in diameter, larger than the Chelyabinsk meteor and carrying proportionally more destructive force. The asteroid exploded in the atmosphere before reaching the ground, similar to Chelyabinsk, but the force of the explosion was still tremendous, still capable of flattening forests across a region the size of a large country. If Tunguska had occurred over a populated city like Moscow or St. Petersburg, instead of over remote forest, millions of people might have been killed instantly. The death toll would have been unimaginable, would have been comparable to a large-scale war. The fact that it struck an empty landscape was simply a matter of chance, of probability, of the random luck that determines where an asteroid will fall as it descends through the atmosphere. The asteroid had no preference for where it struck. It followed its orbit determined by gravity. Where it landed was determined by the Earth's rotation and position at the moment of impact. A few hours earlier or later, and Tunguska would have struck a populated region instead. These historical impacts are sobering reminders that Earth faces a real, ongoing threat from space. A threat that is always present, always possible, always waiting in the orbits of asteroids moving through the solar system. Every few hundred years, on average, an asteroid large enough to devastate a region strikes the planet somewhere. Every 100 million years or so, an asteroid large enough to cause global catastrophe arrives. The Chicxulub impact that killed the dinosaurs is thought to occur roughly once every 100 to 200 million years, based on calculations of asteroid populations and orbital mechanics. That means in Earth's long history, such impacts are not extremely rare. They are simply spaced far apart in time, separated by durations so long that human civilization seems permanent and stable in comparison, so long that we forget that change is possible. The timescale of asteroid impacts is the timescale of geology, not the timescale of human history. An impact of that scale in our present world would end human civilization as we know it. The consequences would be unimaginable. The nuclear winter scenario playing out on a global scale, the darkness covering the entire Earth for months or years, the cold settling like a permanent winter, the collapse of ecosystems and food chains that sustain all life. The agricultural systems would fail, crops would not grow, the sun would not provide enough warmth. Cities would become uninhabitable as supplies ran out and society collapsed. Yet this is a risk that humanity shares with all life on Earth, a risk that has been part of life's experience for billions of years. The dinosaurs did not know about the asteroid that was coming. They had no warning. Modern humans do know about the threat, at least in abstract terms. We can calculate the odds, we can track the asteroids, we can develop defences. This knowledge may be our advantage. In response to this threat, NASA has developed a planetary defence program, a coordinated effort to identify dangers from space and develop methods to prevent or mitigate damage from impacts. This program is dedicated to identifying and tracking potentially hazardous asteroids and developing methods to prevent or mitigate the damage from impacts before they occur. One major success of this program came in 2022, when NASA launched the DART mission, the Double Asteroid Redirection Test. This mission was designed to test whether it was possible to deflect an asteroid by crashing a spacecraft into it, to see if kinetic impact could alter an asteroid's course. The target was an asteroid called Dimorphos, which orbits a larger asteroid called Didymos, a binary asteroid system. Neither of these asteroids posed a threat to Earth, making them perfect candidates for a controlled test. We were not risking catastrophe. The DART spacecraft, a relatively small spacecraft weighing about 500 kilograms, was accelerated to tremendous speed, travelling at over 20,000 kilometers per hour, faster than escape velocity, and deliberately sent on a collision course with Dimorphos. The scientists prepared for impact. The moment came. The DART spacecraft struck Dimorphos at tremendous speed. The impact was successful. The sensors showed that the spacecraft had impacted the asteroid's surface that the collision had occurred. It altered the asteroid's trajectory, changing its orbital period around Didymos by several minutes. This may seem like a small change, but it demonstrated that the concept works, that moving rocks in space is possible. If we detect a potentially hazardous asteroid far enough in advance, decades in advance, ideally, we could potentially deflect it using this kinetic impact method. We could change its trajectory by just enough to make it miss Earth. We could knock an asteroid off its collision course with our world. Yet the success of DART provides only modest reassurance about our future safety. The test worked, which is excellent news, but it worked on an asteroid that was already small and manageable, a relatively easy target. Larger asteroids would be harder to deflect, would require more energy, more impact force, more time, and we would need to detect them decades in advance, giving us time to launch missions to prepare to execute the deflection. A few years of warning would not be enough. We would need a decade or more, ideally several decades. The current survey of near-Earth objects is not yet complete. Scientists estimate that only about 90% of large asteroids, asteroids above a certain size threshold, have been found and catalogued. 9% remain undiscovered. Some of these could pose threats. We have not yet mapped the entire danger zone. There could be another Chicxulub-sized impact waiting in the undiscovered 9%, its trajectory unknown, its arrival unexpected. The work of surveying and cataloguing these objects continues, but it is ongoing and never-ending, a task that will take decades or even centuries to complete fully. As you lie here in the darkness, safe in your bed, consider this. The odds of a large impact occurring in your lifetime are quite low. No asteroid large enough to cause global catastrophe has been identified with a trajectory leading to Earth in the next 100 years or more, or even in the centuries after that based on current knowledge. Current monitoring suggests that the near-term future is safe. We have decades or centuries at least before any major threat from space that we can currently identify and track. This knowledge can be comforting as you drift towards sleep. We are not in immediate danger. We have time. We have a window of safety where we can work and prepare and develop. And with time, we develop better technology, better detection systems, better understanding of how to respond to threats when they come. The universe may be dangerous, but we are not helpless. We are learning. We are developing the technology to protect ourselves. We are building the knowledge and the capability that might someday prevent a catastrophe. The DART mission showed us that. The effort to map the near-Earth asteroid population shows us that. We are taking the threat seriously and preparing to respond if necessary. We are conscious. We are aware. We are ready. Yet the awareness of the danger, the knowledge that impacts do occur, that they will occur again, changes something in how we see our place in the world. We are not the centre of a stable, unchanging universe. We are not at the top of some permanent order. We live on a planet that has been struck before and will be struck again. We exist in a cosmos that follows mechanical, impersonal rules, rules that do not care about our wishes or our safety or our hopes. An asteroid does not choose to hit Earth. It simply follows its orbit, determined by gravity, by the initial conditions of the solar system billions of years ago, by the configuration of planets and asteroids at the moment of the solar system's formation. And if that orbit intersects with Earth's orbit, if the timing aligns perfectly, collision is inevitable. The asteroid will fall. This perspective might seem frightening at first, might seem to diminish our importance, but there is something deeply comforting in it as well. We are not isolated. We are part of a process that is vastly larger than ourselves. The universe is incomprehensibly vast and old, containing billions of galaxies, each containing billions of stars, each star surrounded by planets and asteroids and the debris of creation. The forces that shaped Earth and all of life are forces beyond human scale, beyond human time, operating across timescales measured in billions of years. And yet, we are part of that same universe. We are made of stardust, quite literally. The iron in our blood was forged in the heart of dying stars, created in the nuclear furnaces of supernovas billions of years ago when the universe was younger. The water we drink may have arrived on comets that crashed into Earth in the solar system's youth, the young solar system, the time when planets were still forming and asteroids were still common. Every atom of our bodies has been recycled countless times through the cosmos, from stars to planets to living creatures and back again, a cycle without end. The asteroid that was death to the dinosaurs was composed of material born in supernovae, in stellar explosions. The sulfur that was vaporized in the impact had formed in the cores of ancient stars billions of years before our solar system even existed. The atoms are eternal. Only the forms they take change. Only the arrangements shift. In this perspective, the asteroid that might someday strike Earth is not a foreign invader, but a returning fragment of the cosmos, coming home, reconnecting us to our origins in the stars. As we contemplate the possibility of future impacts, and as we lie here safe and warm beneath our blankets, under protective roofs, we can find comfort in the knowledge that Earth has endured worse. Life has survived worse. The planet that seems so stable beneath us, so permanent and unchanging, has actually experienced catastrophe after catastrophe throughout its history. Impacts from space, volcanic eruptions that darkened the sky, ice ages that covered the continents and glaciers, mass extinctions that wiped out the majority of species alive at that time, and after each catastrophe, without exception, life has recovered. Ecosystems have reformed from the survivors. Species have evolved and diversified and filled the empty ecological spaces. The world has continued turning through the darkness. Seasons have continued their eternal cycle. The sun has continued to rise and set. We are living proof that the Earth can recover from catastrophe, that life can adapt to changing conditions, that the future, though uncertain, has always brought new possibilities and new forms of life. The same resilience that allowed mammals to inherit the Earth after the dinosaurs' extinction 66 million years ago continues to operate today. That same adaptive power, that same capacity to find new ways of living and surviving, exists in all living things, including us. Life is patient beyond measure. Life is adaptable in ways we can barely comprehend. Life endures through time and catastrophe and change, and that knowledge, as we lie here in safety and stillness, can bring us peace. Thank you for spending this evening with the Calm Archive, contemplating the deep past and its lessons for the present. If this video has become part of your bedtime routine, please consider subscribing so you never miss a new release. I upload every day, each video crafted to help you rest and find peace in the vastness of Earth's history. Tell me in the comments, what aspect of the asteroid impact fascinates you most? 66 million years of healing. That is how long the Earth has had to recover from the impact at Chicxulub, from the catastrophe that nearly erased all complex life from the surface of the planet. 66 million years is an incomprehensibly long time from a human perspective. Longer than all of recorded history, longer than all of human civilization, longer than the entire span of human evolution, longer than any span of time that human minds can readily grasp. Yet in the span of Earth's 4.5 billion year existence, 66 million years is a moment, a brief period of time in which the wounds of the impact were slowly closed and the world was transformed once again. The Yucatan Peninsula today, the place where the asteroid struck so violently, is a land of extraordinary beauty and vitality. It is covered in jungle, dense tropical forest where trees rise high above the ground, some reaching 100 meters or more, and create a canopy so thick that little light reaches the forest floor below. Vines and hanging plants drape from the branches like living decoration, connecting the canopy to the ground below. Birds call from the treetops, parrots and macaws and dozens of other species filling the air with sound. Jaguars and pumas move silently through the undergrowth, hunting, living, surviving in the darkness beneath the canopy. Crocodiles rest in the water. Fish swim in the cenotes and underground rivers. The ruins of Mayan temples stand among the trees, monuments built by humans who had no idea that the most catastrophic event in recent Earth history had occurred directly beneath their feet, that they were living on the rim of the world's greatest scar. The ancient Mayan people revered the cenotes deeply, the sinkholes that mark the crater's rim. They built temples around them. They performed ceremonies in them. They viewed them as sacred places, as gateways to the spiritual world, as connections between the human realm and the divine. If they had possessed the tools of modern geology, if they had been able to read the rocks beneath their feet and understand the evidence written in stone, they would have discovered something even more profound and more mysterious. That every cenote they found was a mark of the greatest catastrophe their world had ever seen, a scar from the day when the heavens fell. The cenotes themselves are places of extraordinary beauty and mystery, places that hold secrets within their stone walls. The water is clear and cool, filtered through millions of years of limestone, so clear that you can see dozens of meters down into the crystalline depths below. The visibility is remarkable. Nothing clouds the water, no sediment makes it murky, no algae clouds it green. The water is fresh, sweet to drink, a precious resource in a landscape where fresh water is scarce and valuable. Limestone is porous and allows water to drain through it, so rainwater percolates deep underground before emerging in these cenotes and underground rivers. Tourists come to these cenotes today, during the dry season when the weather is warm and the water is inviting. They swim in these waters, float on the surface, dive down into the crystal depths to depths of 30 or 40 meters or more. They feel the water's coolness on their skin, the buoyancy of the fresh water, the sensation of suspension between worlds. In doing so, they are swimming in a crater formed by an asteroid strike 66 million years ago, resting in the same depression that was created when a rock from space collided with Earth with inconceivable force and violence. They are floating above rocks that were pushed upward from deep within the Earth's crust by the force of impact, rocks that have travelled from miles below the surface to near the surface in the span of seconds, rocks that have been shaped and transformed by the tremendous pressures. Most of the tourists do not know this history. They see only the beauty, the cool, refreshing water, the jungle surrounding the cenote, the sensation of peace that comes from floating in this sacred place. But the geological history is there beneath the surface, written in the rocks, encoded in the mineral composition, waiting to be read by those with eyes to see it, waiting to tell its story to anyone who listens with an open mind. The beauty of deep time is something that becomes clearer the more you contemplate it, the more you allow your mind to expand to encompass these vast durations that are almost impossible to truly grasp. 66 million years seems impossibly long, but it is not indefinite, and it is not infinite. The Earth is not new. The Earth is not ancient beyond all comprehension. It is simply old in a way that human minds can barely grasp without help, without visualization, without contemplation and quiet reflection. The Earth is 4.5 billion years old. Imagine 4.5 billion years, a timeline so vast that your entire life, your entire existence, your entire civilization is less than a blink of an eye, less than a moment in the Earth's story. The dinosaurs existed for 160 million years, from the Triassic period until the Cretaceous-Paleogene extinction event, 160 million years of evolution and adaptation and dominance of ecosystems. That is 3.5 times longer than the entire age of mammals has existed so far. The extinction itself happened in an instant, in the time it took for an asteroid to fall from space to the ground, minutes at most from the moment of entry to the moment of impact. But the recovery took millions of years. The reign of mammals, the age of mammals, the Cenozoic era, has lasted only 66 million years so far, not as long as the reign of dinosaurs, but a long time nonetheless, long enough for mammalian evolution to produce an extraordinary diversity of forms, and humans, anatomically modern humans, have existed for only a few 100,000 years, a recent development on the timescale of this era, barely enough time to blink. Recorded human civilization has existed for only about 5,000 years, the blink of an eye in geological time. Written history has existed for only about 5,000 years as well. And yet we are living proof of something extraordinary and magnificent. We are the products of that impact, the products of catastrophe. Without the asteroid we would not be here, we would not exist. We are the children of catastrophe, and this knowledge is strangely beautiful. The dinosaurs are not entirely gone from the Earth. The extinction was not absolute. Every bird you see is a living dinosaur, a direct descendant, a survivor, a continuation of the lineage that began millions of years before the impact. Every sparrow singing at dawn is a dinosaur that has survived 66 million years of evolution since the impact, evolving and adapting and changing, but never breaking the continuous thread of life that connects it to the dinosaurs of the Cretaceous. Every eagle circling in the sky on thermal currents is a dinosaur. Every penguin diving into the cold ocean depths is a dinosaur. Every chicken in a farmyard is a dinosaur. The lineage of the dinosaurs continued after the extinction event. It did not end with the impact, it merely transformed. The large flying dinosaurs, the pterosaurs with their enormous wingspans, did not survive the impact and its aftermath. The large marine dinosaurs, the mosasaurs and plesiosaurs, did not survive. The giant herbivorous and carnivorous dinosaurs did not survive. But the small dinosaurs that could fly, the birds, the feathered dinosaurs that had evolved the ability to take to the air, did survive. And from those survivors, thousands upon thousands of bird species have evolved over 66 million years. The diversity of birds today is extraordinary and remarkable, from the smallest hummingbirds no larger than your thumb to the largest ostriches weighing 300 pounds, from the songbirds of the forest filling the air with music to the raptors of the open sky, diving at tremendous speed to catch prey. Every bird is a descendant of the dinosaurs, a living reminder that the extinction was not complete, that life found a way through the darkness and the cold, that resilience and adaptation can overcome catastrophe. As you lie here in the darkness, warm beneath your blankets, the world outside is still turning. The Earth is still rotating on its axis, completing one full rotation every 24 hours as it has for billions of years. Seasons are still changing, the tilt of Earth's axis causing the sun to move across the sky in seasonal patterns, spring becoming summer, becoming autumn, becoming winter in an endless cycle. The cycles of life are continuing just as they have for billions of years. Creatures being born and dying, plants growing and decaying, energy flowing through ecosystems, the great wheel of life turning. The night sky above contains stars that shine with light, that has travelled for years or decades or centuries or thousands of years or even millions of years to reach your eyes. Some of that starlight left distant suns when the dinosaurs still walked the Earth in the Cretaceous period, light that has been travelling since before humans existed. Some of it has been travelling since before the solar system even formed, coming from stars that may have already died and vanished, their light continuing on. The light is ancient and eternal, and continues on regardless of what happens on this small planet, in an ordinary solar system, in a rural region of a vast galaxy. You are part of that cosmic story, that vast narrative of the universe. Your body is made of atoms that have been recycled countless times through the cosmos, from stars to planets to living creatures and back again, in endless cycles of creation and transformation. Every atom in your body has existed since the formation of the solar system, or even before, created in stellar furnaces billions of years ago. Every atom is ancient. Your consciousness is a product of billions of years of evolution. Evolution that was set in motion by the asteroid impact that killed the dinosaurs. Evolution that depended on that catastrophe, on that terrible moment when the world changed. Without that impact, you would not exist. You would not be here. You would not be breathing, thinking, aware. This is not a tragic thought. This is not something to be afraid of. This is something to contemplate with awe and wonder as you drift towards sleep, something that brings peace and connection and understanding. The Earth continues to turn day after day, year after year, age after age. The seasons continue to change in their endless cycle. Spring bringing growth, summer bringing warmth, autumn bringing harvest and preparation, winter bringing rest. The sun rises every morning and sets every evening, a daily renewal that has happened for billions of years. Organisms are born and die and are replaced by new organisms in an endless procession of life. Species evolve and adapt and fill ecological roles, responding to changing environments. Life continues in all its diversity and complexity and beauty, in forms large and small, simple and complex, ancient and newly evolved. The oceans are full of fish and other creatures, teeming with life from the surface to the deepest trenches. The forests are full of animals and plants, trees and shrubs and understory vegetation creating multiple layers of life. The grasslands support millions of organisms, visible and invisible, from grazing animals to insects to microscopic soil organisms. The deserts and tundra support their own unique forms of life adapted to harsh conditions. And in the midst of all this vast web of life, in the midst of this amazing biosphere, we exist. We are conscious. We are aware. We can contemplate our own existence and the vast history that led to us, the billions of years of evolution that culminated in our emergence. We can look up at the stars and wonder about our place in the cosmos. We can read the rocks and understand the history written in them. We can contemplate the asteroid that nearly destroyed all complex life and recognize that we are its children, that our existence is the product of that catastrophic event, that we owe our being to a collision that happened when our ancestors did not yet exist. Gradually, as your breathing slows and your mind begins to drift, as sleep approaches like a gentle presence, you can think about this history, this long, slow story of the Earth and life and the cosmos, this story that began billions of years before your birth and will continue for billions of years after your death. Think about the dinosaurs that walked beneath a warm Cretaceous sky, their feet leaving tracks in mud that became stone, unaware that their world was about to change forever. Think about the moment of impact, the instant when the asteroid entered the atmosphere, the flash of heat, the shock wave radiating outward faster than sound, the darkness that followed as ash rose into the sky. Think about the small mammals huddled in burrows beneath the ground, safe from the heat and fire above, surviving on insects and stored food, waiting for the light to return. Think about the first ferns spreading across the ash-covered landscape, green returning to the world, life reasserting itself. Think about the slow recovery, the diversification of mammals, the evolution of primates, the eventual emergence of humans. Think about the long chain of events that led from that asteroid impact to this moment, to you lying here in the dark, conscious and aware and alive, thinking these thoughts. Think about the resilience of life, the way it adapts and evolves and finds new ways to survive and thrive even after catastrophe. Think about the vastness of the cosmos, the billions of galaxies containing billions of stars, each star surrounded by planets and asteroids and the dust of creation. Think about how you are part of that vast system, made of the same atoms as dying stars, connected to everything in the universe through the bonds of matter and energy. The weight of blankets is comforting, holding you gently, a familiar pressure that brings security and warmth. The darkness is familiar and safe, a darkness you have known since the night you were born. Outside, the world continues its slow turning, the same way it has turned for billions of years, the same way it will turn for billions of years more. The Earth will continue, life will continue, species will continue to evolve and adapt and fill niches and find new ways of being. The universe will continue its expansion and its slow aging, driven by forces we're only beginning to understand. And you are part of that story. You're not separate from it. You're not distant from it. You're woven into it completely. Your atoms having been part of stars and planets and countless living things, your consciousness being a product of billions of years of evolutionary process. You are resting, recovering from the day, much as the Earth rested and recovered after the impact, much as life in general rests and recovers. Your sleep is a small death and rebirth, a moment of unconsciousness followed by awareness again when morning comes. The Earth experienced a larger death and rebirth, a death that nearly erased all life, followed by a recovery that led to new forms of life, new ecosystems, new possibilities beyond imagination. And from that recovery came us. From that catastrophe came consciousness. From the darkness came light. From death came new life. And as the night deepens and your eyes close and your mind begins to drift towards sleep, you can rest in the knowledge that you are part of something vast and ancient and beautiful, a story that began billions of years ago and will continue for billions of years to come, long after your own small life has ended. You are the universe contemplating itself. You are the product of stars. You are the child of the asteroid that changed the world. And as the night embraces you, as sleep comes gently like a welcome visitor bringing rest and peace, you can drift peacefully into dreams, knowing that you are safe, you are cared for, you are part of the endless story of Earth and life and cosmos, turning together through the dark, together in the vast embrace of space and time.